Okay, YouTube, this is my third video in my module on factoring, in which we're going to focus on what we call differences of two squares. Okay, so we say a method for factoring the differences of squares is obtained by reversing the special product for the sum and difference of two terms. So basically, in my last set of videos, when we were just multiplying polynomials, we noticed that when you take two what we call conjugates, two binomials that are identical all but for the middle sign here, when you multiply this out, you're basically going to get a squared, or a times itself, minus ab plus ab. So the middle terms always drop out. And then you're going to get b times itself, but it's always going to be a positive b times a negative b. So what we call this is a difference of two squared things, where our a and our b basically are the first term or the second term respectively in each of these quantities. So in words, we say the difference of two squares. Okay, the difference of the squares of two terms factors is the product of a sum and difference of those two terms. So these are really quick factoring patterns. As a matter of fact, we say x squared minus 81 here. We could say that this is like our a squared here minus b squared. So if I said, well, a squared is x squared, what is our a really? I mean, what would be the value of a? We'd say, well, then it's the square root of x squared. It's x. We say, well, if b squared equals 81, well, then what is b just on its own? We say, well, then b would be 9. So essentially what we're saying is, when you factor a difference of squares, it'll always be conjugate pairs. And we can say, well, what goes in the front of this is just the square root of this first term, which is x. And what goes in the back of this is the square root of the second term, which is 9. I mean, this is really a quickly factorable thing. So again, looking at this right here, we say 36x squared minus 25. The thing I notice is that it has two terms, and it's a difference. And these are definitely noticeably perfect squares. So we'd say, well, then this factors into conjugate pairs. One is going to be positive, the other one's going to be negative. And I'd say, well, okay, well, in the front here, we'd have to have a 6x and a 6x. That's the square root of 36x squared. And in the back here, we'd have to have a 5. That's the square root of 25. Done. Okay, so before we tune out of this video, I just want to point this out. You want to make sure that you factor expressions completely. I get a lot of people look at these, they say, all right, differences of squares. And actually, if you don't notice that it's a difference of squares, we could write it this way. You could say it's x squared minus 9 squared. That's our difference of squares here, essentially. So if we were to write this out as conjugate pairs, we'd say, all right, well, it's going to be conjugate pairs, plus minus. What's the square root of x to the fourth? Well, it's x squared. That's this thing here, right? Okay, x squared. And what's the square root of 81? Well, I get a 9. The only reason I say you need to make sure that you have factored all the way is because I noticed that, check this out, this is also a difference of squares. I mean, like, we could break this down even further into x plus 3, x minus 3. Okay, and on that note, I do want to point this out. You cannot factor a sum of two squares. Okay, so we'd say this is a perfect note to write down. Sums of two squares do not factor. Okay, but differences of squares do. So looking at this last example, we'll bury this one here. We'd say, okay, well, I noticed that 81x to the fourth is a perfect square of 9x to the second. That's definitely a perfect square of that. And we'd say that 16 is a perfect square of 4. So again, looking at this, look at that. It's a difference of squares. So rewriting this, we'd say, well, then I've got my 9x squared plus 4. I mean, that doesn't factor because, right, we said that sums of squares don't factor. But this one does here. It factors into conjugate pairs. It's a difference of squares. There we go. And we'd say, well, the square root of 9x squared is 3x. And there we go. How about that? And the square root of 4, is 2. And this isn't a difference of squares, but luckily. But we're done, okay? So that's how you factor difference of squares.